Welcome to Precalculus Concept 13C. Using factoring to find zeros of a polynomial function. There's 5 boxes. Let's begin right away here. Box number 1 is all about vocabulary, okay? We have to understand these words before we can move on into the lesson. So let me shrink it down for you so you can see the whole thing. Okay, these 3 words right here, zeros, roots, and solutions, numbers 1, 2, and 3, they all mean x-intercepts. X-intercepts. And what are x-intercepts, you might be asking right now? X-intercepts are where the graph crosses the x-axis. Okay, so if you hear me talking about zeros, roots, or solutions, that means I'm talking about x-intercepts. And of course, x-intercepts are where the graph crosses the x-axis only. So this point right here is a root, a zero, or a solution. And that point right there is a root, a zero, or solution. Okay, so let's do example number 2. Let's find all of the zeros, now remember what those mean, of f of x equals x to the third plus 3x squared minus x minus 3. So check this out. Here is the graph. I have graphed this picture for you. And I'm going to make it a little bit bigger. And so what we want to do now is determine all of the zeros. Well, if I had to determine the zeros just from looking at the graph, I would say that there is one zero there, there's another zero there, and another zero there. So I would say the zeros are x equals negative 3, x equals negative 1, and x equals positive 1. Okay, box number 3, we're going to do this one without the use of a graph, and then we're going to check our answer and see. Okay, so the title of this lesson is all about factoring to find zeros. So take a look at this. I have f of x equals x to the third plus 2x squared minus 4x minus 8. So you'll notice right away that I have 4 terms. Whenever you have 4 terms, you want to think about factoring by grouping. Factoring by grouping. So I'm going to go ahead and group the first 2 terms together and group the second 2 terms together. So in the first group, if I take a look at x cubed plus 2x squared, I can factor out an x squared. And that would leave me with an x plus 2. Okay? Now, if I take a look at the second group of negative 4x minus 8, I can factor out a negative 4. And that would leave me with an x plus 2. So remember how factoring by grouping works. Notice I have a common factor, so I can factor that out. So I end up with x plus 2 multiplied by x squared minus 4. Now you should recognize that this is the difference of 2 squares, so I can keep going. So I could say this is going to be x plus 2 times x plus 2 times an x minus 2. So these are my zeros, or excuse me, this is my factored form of this polynomial. So I have now factored that polynomial into a product of linear factors. So from here, if I want to find the zeros, I want to find where this crosses the x-axis. So if I want to find the x-intercepts, I always set y to 0 and I solve. So I get x plus 2 times x plus 2 times an x minus 2. So from here, we can invoke the zero product property, which simply says that if any 2 or 3 or 4 or 5 numbers, whatever it happens to be, multiply together to get 0, then one of the answers has to be 0. So this tells me that either x plus 2 is worth 0, or x plus 2 is worth 0, or x minus 2 is worth 0. This tells me that one of the zeros is x equals negative 2. This tells me that one of the zeros is x equals negative 2. And this tells me that one of the zeros is x equals positive 2. Now you may notice that there are 2 zeros that are exactly the same. That's called a multiplicity. We're going to get into that into a different lesson, but here's a little heads up about it. It's going to affect the graph in a certain way. So take a look at our graph over here, and this is the part you would do in your calculator afterwards. So check it out. At negative 2, you can see that the graph actually touches and then turns around. That's because it has a double multiplicity. Again, we'll talk about that later. And the other zero that we found is x equals 2. Which of course is right there. So my zeros are negative 2 and 2. Okay, box number 4 is another example. Let's find all of the zeros together. So for this one, I'm going to go ahead and factor what I can. So this is going to give me, if I go over here, I'm going to factor out an x squared from this entire thing. Okay? That's going to give me a negative x squared minus a 4x. And then minus a 4. Okay, so I have x squared minus a 4x minus a 4. Now I'm going to factor out a negative 1, since you are allowed to do that. So I'm going to say this is negative 1, so negative x squared. Leave me with an x squared plus 4x. Hold on a second. This should be plus. So now this is going to make this a minus. My bad, guys. Sorry, give me 1 second. Okay, this should have been a minus sign. So minus 4x, and then this is going to be plus the 4. Okay, good. So now I'm going to go ahead and try and factor this thing right here. So I have negative x squared. I'm going to factor this to probably an x and a 2 and a 2. And let's see here, negative and a negative. Yep, there we go. That makes sense to me. So I factored, and then I want to find all the zeros, so I set this thing equal to 0, and I invoke the 0 product property. So either negative x squared is worth 0, or x minus 2 is worth 0, or x minus 2 is worth 0. Solving this one, I could see that 0 is going to be a solution. So x equals 0 is a solution, or x equals 2 is a solution, and x equals 2 is another solution. So I have 0, 2, and 2. So again, if I look at my graph over here, I see I have a root at 0 and I have a root at 2. Notice the one at 0 also turns around. That's because it's a double root 2 because it's squared. And then notice the one at 2 turns around as well. But for the way that we answer this question, the zeros are at x equals 0 and at x equals 2. Okay, box number 5 is a you try. Here you go. Find all of the zeros by factoring this polynomial and check your answer by graphing it in the calculator. Okay, so the answer is x equals 0, x equals negative 2, or x equals positive 2. So I started by factoring x to the 4th minus 4x squared by taking an x squared out, leaving me with x squared minus 4. That's the difference of two squares. So that's going to be x plus 2 times x minus 2. Solve using set it equal to 0. Solve using the 0 product property. So I can see that 0, 2, and negative 2 are my answers. And check it out. If I check this with the graph, you can see I have 0, negative 2, and 2 are my zeros to that polynomial. So hopefully you got that part right.